Hello. I'd like to present you the two next panelists. Johannes Dimas, who is an energy specialist of offshore wind, and Edson Watanabe, who is a full professor of COPPE, Federal University of Rio de Janeiro. They'll talk about wind offshore and other renewables questions related to wind energy. So let's start with Johannes, and then we'll have Watanabe.
Okay, thank you for the introduction. I'm Johannes Dimas, working since 20 years in the offshore sector, and I'm also present in Brazil. I live in Brazil, in fact, now with a new company, and I'm consulting governments and international and now also local companies of the offshore industry and of the emerging industry here in Brazil. Well, today I will give a very brief introduction about the offshore wind energy industry, about offshore wind farms, and then I would like to focus on the Brazilian market. So I will hurry up for the first slides to have some time to talk about Brazil. First of all, I show here a global overview. In the end of 2020, we already reached 30 gigawatt installed capacity worldwide. As you can see in the figure, Europe is still the biggest market, but in particular, China hurries up. From the 8 gigawatt which are now under construction, more than the half are currently under construction in China. Altogether, it sums up in 157 wind farms, 105 of them in Europe, 50 in Asia, 2 in USA. But we have to consider that there will be certain growth in other Asian markets too. For example, Taiwan, Vietnam, and other countries preparing wind farms just right now. So what we can see, offshore wind energy is really globalized. All this has to do with economics. So here's a chart which shows the new asset finance of offshore wind energy. Here with the scope of Europe, whole Europe, not only the European Union. And in 2018, you see 10.3 billion euro were invested, and this for 4.2 gigawatt new asset finance. When you imagine that even China just right now have more gigawatts under construction, you see what will the future bring. An important issue for understanding offshore wind is the levelized cost of energy. We say that means what is the final cost to produce the energy, including every single cost position of this project over the whole lifetime, including construction, deconstruction, maintenance, and so on. And what we see is nowadays globally, it's about US dollar in this case, 0.115 US dollar per kilowatt hour. But in particular, the auction and tender results showed that IRENA, these are IRENA figures, talks about 2023, actually might be even a little bit earlier. They dropped down to 0.05 to 0 or up to 0.1 in this range dollar per kilowatt hour. And IRENA, and this is also shown in Asia, believes that this can also be achieved in relatively new markets, like Brazil, for example. Well, to give a little bit proof about that figures, I just gave here a table with the German auction results. And what you can see in the very right column, you see that there are 0-cent bids. It's the North Sea, the Baltic Sea. We have two different seas in Germany, and some of them are 0-cent bids starting from 2022, 2024 in terms of commissioning. And this means they do not ask for any incentive anymore with regard to the production, but you have to be aware in Germany, the grid connection up to a certain point offshore is provided by the transmission grid operator, and this should be understood as a certain incentive. Well, we are not all offshore experts, so I want to give a very brief idea about an offshore wind farm, the system. What we see here is a schematical draft of an offshore wind farm. I was involved in the construction and planning and purchasing. So of course, this consists of much more turbines. It's much more far away from the coast, like it is shown here. With a crew transfer vessel, you need 2 hours to reach the offshore wind farm. In this case, it's about 60 to 70 kilometers from shore. And an offshore wind farm, of course, it has the turbines, which are physically pretty similar to the onshore turbines, but they are adapted in terms of reduced maintenance works by introducing duplicate parts, redundancies. Also, this harsh environment with the salty air has to keep out of the technical inside, so they have certain measures to control the atmosphere inside the turbine. Then we have the tower, a transition piece. When you go down to when you follow the tower down, then you see a transition piece with a platform where people can access. So this is an access platform. And such a transition piece in this case, for example, only has a weight of 400 tons or something. So it's pretty heavy steel work. And below, partly in the water column, there's a foundation. In this case, this is the first phase of a project which has 2 phases. And in the first phase, we use tripod foundations because there were not monopiles at this time available to put these heavy machines only on a monopile. I will describe later how a monopile looks like. Then the power which is produced is transported in an in-array cable, which is buried in the ground to a transformer station. In Germany, we have big transformer station of the transmission system operator who collect from several wind farms and transport to the shore. I will not point out that more because this will be topic of the next presentation, the grid connection. So here only a picture of our construction work. I just would like to highlight that even special vessels were developed to bring down cost of offshore. This is in 30-meter water depth. This vessel is really big. It can carry 3 sets of turbines. So you can see 1 rotor blade is still there. So 2 were already installed in this turn, in this cycle. There are more than 100 people on that vessel. We have sport area there, everything. So it's a huge, huge action to construct such an offshore wind farm, but it seems to be worse. On the bottom picture, we see the loadout in Eemshaven, the Netherlands. In this case, even the project is in Germany, because this was the closest suitable construction harbor. I already mentioned the substructures. The tripod foundation we used in that project I did show. In the same project, second project phase, only 2 years later, we used already monopiles, even we had bigger machines, because the monopiles were developed, the diameter of the monopile foundation were bigger, could bear more capacity in terms of load. could be installed in deeper water depths, because water depth is very relevant for the choosing the foundation type, of course the ground condition too. And the monopiles are the most preferred foundation types in Europe, in newer projects, because they're really slim design and easy to mount. Disadvantage is it makes a lot of noise when you pile them. Now floating foundation getting a new trend for sure. I heard just recently that the insurance also are fine now with the design, so they're ready to be rolled out in bigger amount in future projects. They're existing already pilot projects. On the left side, another type of foundation suction bucket, which is a bucket and then actively gets sucked into the seabed. But this is a decision from project to project, which kind you would like to choose. Here's a picture from Bremerhaven, Germany. And you see here for two different projects, actually 3 different projects, but you see 2 types of substructures. The jacket structure, this is for global wind, the wind farm, and on the left, the tripods for the Trianel wind farm. I did already show the pictures. Just to get an impression of the size, have a look on the right side. The crane you see there's the type of crane, the biggest one who is allowed to drive on German roads. So this is really huge steelwork. Down the picture below, this is from the website of Trianel. It's made from the helicopter. You see the installation, the piling of the piles of the tripod, because the tripod is not standing like a gravity foundation just on the ground. It gets piled into the ground. And what you see here is this white circle. This is an artificial curtain of air bubbles made by a pipe which leave out air bubbles, and this reduces the pile noise to protect in particular mammalians around. Actually, you start making noise slowly so that the animals have a chance to leave the area, but then additionally you have this bubble curtain to reduce the noise. So now we talk about the system, the technique. Let's speak about offshore wind farms in terms of project phases. An offshore wind farm has a very long life cycle. It's more than a generation, let's say. That's why usually people like me work on several projects, because it takes so long. We start usually a project with a project development, a feasibility analysis, a certain engineering, basic engineering, to approach the approval authorities to start the approval procedure. But later there's a detailed planning, tendering. With tendering, I mean in this case, tendering the supplier, like manufacturer of turbines, foundations, etc. Yeah, and when you have an agreement with your suppliers, then the fabrication starts, then the construction, 20 to 30 years operation, and in the end, the decommissioning. We already have some few wind farms which were decommissioned. On the button, we see some milestones. I would now highlight a little bit the project development phase, because this is the one where we are here in Brazil. So companies seeking to find the best positioning of a potential offshore wind farm, they make spatial evaluation, they identify some sites, they make further investigation, they define a certain site where they would like to locate the offshore wind farm. This includes where are shipyards, ports, grid connection, how's the water depth, is there any environmental issue to consider. So there are a lot of factors to be considered. And then you start your approval planning, and during this time you have to make also several site surveys, like maybe wind condition measurement, ground conditions, and also, of course, all the surveys with regard to the environment. The final target is to satisfy a potential investor. If you work in a bigger group, like I did in Vattenfall or Equin or in these companies, you have to convince your board. If you're a free developer, you have to convince your investor, and this means also convincing banks, convincing insurance, convincing certification bodies, and so on. And it's very important that you're targeting your project development to the demands of the market. Well, remains the question, why should I go offshore? Brazil has so much space, we can do onshore. But there are differences which makes offshore economically reasonable. In particular, these are the outstanding wind conditions. On sea, we have higher capacity factors, and just a little bit more wind means earning a lot of my energy yield, which is somehow equal to money. And this is because if the wind is stronger, the energy yield does not increase linear, it does increase cubic. So 2 times more wind, 8 times more energy yield. There you can see if you have a better wind, you earn much more money, and this is enabling offshore. There are also other advantages of the wind situation offshore, for example, regarding the profile. So let's simply say the wind is more laminar and you have less wear and tear due to turbulences. There are spatial aspects. In Germany, these are the space constraints. Here, maybe it's because there are big cities close to the coastline. In Asia, this is also an important argument. Of course, in the beginning, the incentives was a good reason to go offshore. But as we see nowadays, incentives fading out, first projects, or many projects indeed, get realized without incentives. But for starting market, incentives are crucial. Well, why offshore? Of course, the politics have certain reasons to push that. This is in particular related to reducing the carbon footprint. This means not only in the electrical sector, but in the all over sector. So you will use much more energy in future because you use it more also for the transport sector, or for example, for producing green hydrogen. Germany is calling all countries all over the world to establish a hydrogen economy in their countries, in particular in these countries which has as cheap production possibilities for renewable energies like Brazil, Chile, other countries. So they call them to think about hydrogen because Germany and other European countries, they need to import hydrogen to meet the climate targets. What is the motivation from the market player? Okay, the developer in Germany at that times when it started 20 years ago, they searched for investment targets or alternative investment and development targets to substitute their onshore business. The manufacturer and supplier at that time saw emerging business opportunities, but we have to understand this is already a mature market. There are experienced people, so there's nobody need to be convinced anymore, let's say, in this region. Interesting is why equity capital. So because Brazil, if they realize an offshore industry, they need to ask for equity and debt capital. The investors are there. There's a lot of money out. You could see it in the financial crisis. There was still money because the problem was not there was too less money. The problem is there are too less projects, and offshore projects are ideal for big investors, big utilities, in particular in times of low interest rates. And the debt capital is the same. When we started the first project, we had 25 banks in the consortium to finance our debt capital, and nowadays it might be 5. And this shows how the risk assumption of the banks were reduced. Why in Brazil? Okay, we see here on the left a wind map from the World Bank, just to indicate there are certain areas which have really high average wind speed or wind potential. So we have a wide coastline, extraordinary wind condition with very high capacity factors. This is really globally extraordinary. It combines well with the existing hydropower here in Brazil. Brazil is anyway acknowledged as an investment target for clean energy investment. We have vital development activities of various players here in Brazil. So we have projects already in the greenfield stage. I will come to that later. And of course, Brazil has already a very green electrical energy matrix, but the total matrix, still more than 50% are not renewable. And the energy transition demands for even more electrical power to substitute fossil power, mobility concept, and so on.
Johannes, you have more minutes, okay?
Yeah, how much?
2 minutes.
Okay, obrigado.
Okay.
Okay, and the globalization, of course, leads to the fact that we have also investors in place and the global supply chains. This is a short, quick overview about the projects in Brazil. So we see, I cannot read it now because it's hidden, but I think it was 15 gigawatt in the pipeline. In terms of they have requested an approval procedure with IBAMA. Okay, so that was my last slide. Sorry, I was a little bit longer. I would shift the discussion of the main question, next big market in Brazil, maybe to the discussion round later, where we can discuss in particular the situation here in Brazil. Thank you very much.
Thank you, Johannes. I think it's better if we put all the questions after the presentation of Watanabe, if you agree. Okay?
Yeah, yeah.
Because there's a question already for you that the audience sent us, but I think it's better if we shift to Watanabe and then you answer all the questions, both of you.
Yeah, I totally agree. Yeah.
Okay. Watanabe, it's your turn.
Okay, let me start. It takes. Okay, let me start talking a little bit about myself, because the Dimas is a specialist in wind energy, especially offshore wind energy, but I'm not. I'm not a specialist in wind energy and even offshore or onshore. I work with power electronics, and in power electronics, what we do is just to work with energy conversion and processing. And for instance, the connection of variable renewable energy to the grid is a problem that we like to work on. It could be also fuel cells, and we also work with energy quality. We have to deliver to the consumer energy with given quality. And I also work with high voltage DC transmission. Here below, I'm going just to point out some difference between various types of engineers that work in electric power systems. We have people working with the planning, and those people normally they have a time scale of weeks, months, years. And in power system, we have people that work thinking about hours, days, or weeks. And some people working with transient problems. No? Those people think about millisecond, second, maybe minutes. And power electronics goes far below, we normally are worried about the phenomena at microsecond, millisecond, and normally it's up to second, and from time to time we go to minutes, but normally we work at very, very small time scales, because this is the where the converters works. Okay, it's taking time to change the slides. This question, why we should go renewable? I think that the answer is obvious, but in my case, I had an experience that made me more worried about this problem. I visited Beijing in 2011, and on the first day at 6:30 in the morning, I went out for jogging, and I took this picture where I saw the sun rise, and the sun was a little bit orange. A few days later, I went to visit the Great Wall, and everything was white. First, I asked if that was the problem of the the weather, but it was not. This is basically pollution. And after that, I stayed there 1 week and couldn't see blue skies. And I started talking about this problem. Then I commented once that this orange sunset basically is pollution. It may basically it is NOx resulted from the fossil fuel burning. And interesting that at least in Rio, there are many people that go to the beach just to look for the orange sunset, and they even clamp their hands, thinking that this is romantic, it's nice, but this is pollution. So I don't know what to do exactly, but we must stop burning fossil fuels. And after that experience in China, I started to take a picture not of the sunset or sunrise, but trying to find blue skies. And I also, from time to time, someone is always sending me picture of the skies. And the first one I took myself, it's the sunrise. This is a very clean air. Another one is in the south, and the last one is a picture I took when I visited our wave to electricity converter in close to Fortaleza in Pecém. But I was interested in this blue sky. So we have to find ways to keep those blue skies. And first thing is to stop using fossil fuels and move fast to renewables. And just to inform, I stopped using gasoline since 2006. I use only ethanol. This is something that we can do here in Brazil. Okay, I think Johannes talked well about the why renewables. So I skipped these two slides and just say that the objective of my presentation here is to talk about the electric energy transmission and connection to the grid. Part of my talk is based on this roadmap that was published by EPE, I think last April. And I found some definitions there. The first one is wind turbine. It says that has blades, rotors, tower, nacelle, and other devices. I work with other devices, that's generators and converters. And I also found the definition for connection. It includes cables, substations, converters, transmission, and connection to the grid. In this roadmap, there is also some number about the potential of wind energy in Brazil, and there's a large difference. The highest one is 600 gigawatts, and the smallest one 370 gigawatts. But anyway, there are lots of power to get from the from offshore. So why to talk about connections? In the case of onshore connection, we can see that the cost share shows that 73% of the cost is due to the wind turbines and 10% due to the connection. But when you move to offshore turbine, it's more expensive, but it just costs 40%. And the connections is more than double. It's 21%. Of course, construction and other capital costs are also more expensive. So I think it's important to take care of this connection. But before explaining how we can do this connection, it's important to just to give some concept on how hydro and thermal generation works. Normally, when you have a hydropower plant, you have water, you have the turbine, and controlling the water flow, it means you're controlling the fuel. You can control the turbine speed, it means you control the frequency, and the generator control the voltage. And this is delivered to the consumers, and the consumer can switch on or off their loads, and that's okay. So what we have here is what we call that this generator, the system operates as a grid former. It forms a grid, and if you have a grid, you can use the energy as we do today. We just turn on the light, and the light is on, we turn off, very easy to do. But when we move to wind or solar, we do not have control on the fuel. We cannot control the sun, the wind. So what we do with the converters is to inject the maximum power from the wind or from the sun. That means that we operate at maximum power point tracking, where it's called MPPT. And this means that this generation from wind and solar, they work as a grid follower. And if you have a grid follower, of course, you need to have a grid. And to have a grid, you have to have a hydro or thermal power plant, and then you can connect to the grid. The important conclusion from this is that basically today it's not possible to supply a grid only with wind or solar. You still need to have a hydro or thermal power plant. If you have this power plant, you have the grid, and then you can connect the solar or wind farm. And maybe in the future, we will have converters, very large converters, with energy storage, maybe batteries, that will be able to replace the hydro or thermal power plant. But today, this is not possible, or maybe it's possible, but too expensive. So, as I said, now, if you have here a wind farm, you need to have a grid to connect the wind farm with the grid. The best thing to do is to put some connection between the onshore grid and the offshore AC grid. The problem is that when you go to offshore, in most cases, it's impossible to construct overhead transmission line, so the solution is submarine cable. But submarine cable in AC, normally it has a distance limitation or power limitation. I would say that it's difficult to go more than 100 kilometers or probably more than 100 megawatts. So you have a limitation on the AC transmission. In this roadmap, I found also low frequency transmission, but I think this is not the case. I'll skip it. And the other option is the HV high voltage direct current transmission, HVDC transmission. Basically, if the power is above 100 megawatt and you have 50 or more kilometers from the generation to the connection point. So you have here AC grid close to the wind farm. You need an AC to DC converter, DC cables, and then you have to convert again from DC to AC and connect to the grid. Well, as I said before, I need close to the wind farm a grid with voltage and frequency controlled. So this converter, AC to DC converter, has to operate as an emulator in hydropower plant or thermal power plant, and it has to absorb all the energy generated by the wind farm. This is a characteristic that it's important because, for instance, in Brazil, we have 20 gigawatts of HVDC transmission, but our HVDC transmission is based on a device called thyristors, and this is not good for this kind of application. In this kind of application, we have to use a newer technology, with maybe a little bit more than 10 years. No? And then, of course, we have to use cable, DC to AC converter, and this converter has to inject all the energy generated by the wind farm in the AC grid. And of course, this AC grid has to be able to absorb this energy. This is the picture of the first HVDC system. It's a Wind 1 in Germany. And you can see here that it's the converter has about 20 meters, which means something almost like a building of 7th floor, 5,000 tons. This is built onshore, and then you have to transport to this place and then put on those pillars. So when I see this, it looks like something very, very complicated. It's operating since 2009. And I think last year, a bigger one was commissioned with 900 megawatts. And this converter station was equivalent to a 15th floor building that also was built onshore and then transported and put on the pillars offshore. So when I see all the size of this project, I think that we have to learn how to save energy because it's a very big system. Well, the tendency now is that there are many works talking about multi-terminal HVDC, where you have wind farms and different wind farm connected to a DC grid, so you can use one grid to inject energy in one point, AC grid 1, or you can send to AC grid 2 or more. So this is a concept that is being developed now and maybe in practice in the near future. Well, I'm getting to the conclusion. So conclusion is that due to distance and the power level that we have in offshore wind farm, HVDC transmission may be the best solution for future offshore wind connections. For the next future, I think multi-terminal HVDC may be a good option. And I did not talk about energy storage, but I think that energy storage connected with wind farm may help to transform wind farms, especially offshore wind farm that has very stable wind and very predictable wind. So that if you have a prediction of the wind and a small, not so small, but energy storage, it's possible that you can transform it in a source that it will be dispatchable. So you can predict how much power you can get exactly, for instance, tomorrow. So you can count on this. In many cases today, the power is too variable. Well, this was my last slide. I would like to thank the invitation to be in this panel together with Johannes and Claude. Thank you.
Thank you, Watanabe. Now we can start the debate. So we have two questions already from the audience, both to Johannes. Johannes, I don't know if you received the question that I sent you, but I will read it anyway. I sent you.
Better. I don't see them right now. No.
Oh, so I'll read it anyway. So it's a question from Gabriel Cavados. He says, this week the Brazilian permitting authority, IBAMA, released the reference term for the permitting process of offshore wind farms. In the document, the agency showed concerns on the visual impact of such projects. So his questions are, is this something that happened in Europe as well? And can you comment experiences of mitigation measures? So this is the first question.
Yeah, well, so the visibility of an offshore wind farm, in the end, it's an objective issue. It has. And the question is how that affects whom. And usually this is tourists and people. And in Germany in particular, we are very far out. We are about 60 kilometers out there. We have not really very closed wind farms. This was due to the project developers just tried to get their approval and did not want to make a bigger fight, let's say, but it's also related that we have a lot of protection areas in front of the coast. So what I would like to say is there are computer tools who display how the wind farm will look like and how many days. I'm not aware about the simulation here in Brazil, but in Europe, in particular North Sea, even if you can see a wind farm physically, you see it anyway, 200 days of the year not, because the weather is with fog or something. So in the end, you make a visualization, and then you have to particularly decide on for each location if you want to bear that impact or not. Because wind farms can also attract people. We have really problems sometimes in the wind farm because people coming there with their boats. That for me would mean the first project should be allowed to have a certain visible impact, 1, 2, 3 projects. and the following should go further out to reduce the total impact, because impact is always an addition of various impacts. So to have in this Brazil coastline 2-3 spots where you can see a wind farm, also maybe pretty close, let's say 30 kilometers, that's okay, but you cannot build all the capacity in that distance. I hope I met the answer. You can actually use, just if he's interested, you can actually use the onshore tools like Wind Farmer, and which are used for onshore visualization. You can use approximately also offshore. They are not totally correct, but you have an impression. Instead of a green field of grass, you just imagine the ocean, and then you can see what distance, how they appear. But this is very rough. It's not actually true. Offshore has some other conditions.
Okay, thank you, Johannes. Now we have a question to Professor Watanabe. Does the intermittency can reduce the efficiency of the transmission?
It was Amaro that made the question. First, I would like to comment that I think last week I was in another meeting, and some people were using this word intermittency. But people that were there defending the wind and solar, they say that it's not intermittency, but it's maybe the word they say is variable, because especially in the electric system, people normally they connect the intermittence to some kind of fault, but this is not kind of fault, just because the wind is variable. Well, the question about the efficiency, of course, if you have full power transmission, normally the converter have a higher efficiency or close to the maximum efficiency. When the power goes down, the efficiency falls. But I think that this is not a problem. Probably this difference is very small, and it's not. I would not worry about this. No?
Okay, thank you, Watanabe. Now we have another question to Johannes. So Brazil have a very huge oil and gas industry. How those industries can accelerate the wind offshore in Brazil? In your opinion, what is the main investments the harbors must be done for the next new market?
Well, first of all, many oil and gas companies are already nowadays involved in offshore wind. Some even changed their business model. So there, of course, are a lot of synergies, in particular with regard to knowledge. But we should not forget that the margin of an offshore wind farm is much smaller than a margin of an oil and gas field. So we have to do everything much cheaper. And that means that many solutions which are used in offshore oil and gas has to be optimized on wind energy, and we cannot think that we can use the one sector for the other sector. So these are two different sectors. Actually, here in Brazil, also they are in two different places. So we should not think, we take an engineer from offshore wind of oil and gas and put it in our team because this engineer is so expensive you cannot pay. So this has to do with the different margins. I understood that there was also the question with the ports. The ports, many people talk about ports, but depending on your, in particular, foundation strategy, you maybe need a shipyard. You need, of course, port areas, a lot of areas, which is plannable and I think not very competitive to the oil and gas. But the shipyards, if you have to construct, for example, tripods here in Brazil, because you will not transport them from far away, then you need really shipyards and book them. And of course, there might be also some bottlenecks. And if you have monopiles, you can even import them from Asia. So there's a kind of competition, but not too much. And later in future, they all could come together because, of course, offshore could also feed oil and gas electricity demand. And even more in future, when we have a hydrogen economy, offshore is a good source to produce hydrogen. Then we have also this storage measure, but the oil and gas industry with this refinery knowledge and so on, of course, will also participate on that hydrogen future. Hope that meets the question.
Well, now we have a question to Watanabe, which is it correct to say in electrical aspects that electrical charge is electrical charge and it doesn't matter where it comes from?
Yeah, of course, when you use electric energy, it doesn't matter. The problem is that when you have hydro or thermal, when I turn on something here at home, someone is controlling the turbine there to increase the power. So you can use basically any time. When you have wind, if there's no wind, you will not be allowed to use this energy. This is the problem. So that's in this way, we need to have hydro or thermal. It's better to have a hydro. And always that you use energy, if you have wind, normally you have to use energy from wind and that just keep the water in the dam. This is our big storage system. And in this sense, if we have the storage and the renewable, there's no problem. The problem is if you go increasing the renewable, the variable part, in some level of power, probably we'll need to add some storage in the system. If people keep on using energy when they want. Maybe the concept of smart grid will help in this. For instance, if you have a lot of wind, you can charge your car, you can generate hydrogen, but if there's no wind, you stop charging the car, you stop washing clothes and so on. We will have to learn how to use this energy.
Mm-hmm. Okay, so now we have a question to Johannes. In North Sea, is there any offshore wind power plant that produces electricity to different countries?
Actually, there were plans. I'm not sure how much they are realized with the Dantes project. There's also, let's say, brother project in Denmark. But what is existing, in fact, and I was involved in the grid connection, was project leader there. We made a grid connection to Kriegers Flak. There's Kriegers Flak 1 and 2 in the Baltic Sea, so in the east. And there we already considered, and this is now actually in operation, a connection to Denmark. So we have now a direct connection through the Baltic Sea from Germany to Denmark, and in between there's an offshore wind farm. So the offshore wind farm can somehow choose where to feed in, who needs the power to stabilize the grid, Denmark or Germany, and even if in the German grid is too much, they can even give the power through to the other country. And this, of course, is part of a smarter solution. In general, in the North Sea, the transmission system operator there, TenneT, is planning a full offshore grid so that everything is connected, also with the Netherlands and so on. It's existing in Germany. I'm totally aware that this is in the Baltic Sea. In the North Sea, as far as I know, it's more in the planning state. Of course, this has also tremendously impact on regulation, and also the grids has to be synchronized because they have a certain tacting, and of course the grids has to fit together. But in Brazil is so big, they could make their own exchange only within the country.
Mm-hmm. I do have a question also for you, but there is another question to Watanabe, then I'll ask mine after that. So is it correct to say, oh no, this is the question that I've already asked, sorry. So I can, so I would like to ask for both of you, if you think there are any environmental impacts also related to wind power plants, or can we say this is a kind of energy that would be with very low environmental impacts? What do you think about this kind of renewable energy in general?
Who wants to start?
Yeah, you can go.
Yeah, okay. Offshore wind energy has an impact on the environment, that's totally clear. Sometimes if you focus only on that sector, you should not forget to compare it with other sectors. For example, offshore wind energy on the wrong place may have a strong effect, for example, on birds. So you have to plan accordingly to reduce the impact on the bird population, in particular on the mitigated birds. But you can mitigate these effects even further. For example, in Germany, if there's a wind farm close to mitigation roads, they be able to observe the birds, and if there's a mitigation which takes, because of the weather, the birds sometimes flee like the tourists, and they come back, they go to Africa and come back. So they know pretty well when they're coming, and they observe them. They have even electronic things on their top, and then they shut down the wind farm indoor. And there's also an impact in terms of diving the piles into the sea. And also this you have to mitigate, for example, with the bubble curtain I showed. So there are a lot of impacts, you have to be aware of them, but it's always a matter of scope, also compared to the alternatives you have. And in the end, if you see in Germany, somebody counted once, I not remember the figure, but how many birds get killed by cats, by house cats? Yeah, this is much more than the wind turbines in Germany killed. It's just, you know, you have to put it in relation. And offshore wind energy, the biggest problem, or in Germany at least, and maybe we have to be aware here in Brazil too, the biggest impact would be if a ship collides with an onshore wind farm, and the ship would be the impact, not the offshore wind farm. The turbine can fall, everything, and that's why the turbines are constructed in a way that when a ship hits a turbine, the turbine is constructed to fall in a direction that it does not hit the ship. So even this can be mitigated. And so you have to make risk analysis and try to mitigate all the risks. And also, for example, in Germany, and this is a synergy to oil and gas, you can have some capacities of tugs prepared that when a ship loses navigation, the tug goes out and take it. When we construct, we have always tugs there. As soon as a ship comes, we go there and say, here and no more. So if we have a drunk captain or something.
Okay, thank you.
Okay, let me comment on this. I think that everything we do have some impact. We have to know if it's a large impact or small impact. Some years ago, I was just thinking how much CO2 I was generating myself. We have to breath, and I expelled some CO2. And I talked with some colleagues at biomedical engineering, and then after some calculation, we got the number that about 250 kilograms of CO2 per year. At the beginning, I thought that's too much. I should clean it. And then I start to think maybe I should stop brushing, but it's not a good idea. And then I found out that basically what I generate of CO2 comes from rice, beans, a little bit of meat, which came from the air, from CO2 from the air. So in principle, it is sustainable. It is no problem. And then I started to breathe without problem. But to have the rice, bean, and so on, someone has to cut the trees and put use some land. But I decided that this is a small impact. That's not so big. So I'm normally eating not too much. I'm trying to keep the weight. So I think we have to do something like this. Once I received one professor from Germany, and in the email, he wrote that he would like to talk about wind energy, but he was not exactly someone from energy. He was, I think, biologist. And what he wanted to talk was just to say that offshore wind was not a good idea, because if you put the wind turbine there, you get energy from the wind. The wind behind the turbine will have a lower speed. This would affect the waves, that would affect the oxygenation of the water, that would affect the production of plankton. But I'm not sure, but there are people worried with many things. Maybe for now, I think we can consider that this is a small problem. Like in my case, I'm brushing normally without problem. I don't know how long, but for now, I'm brushing normally.
Okay, thank you. Thank you both for the answers. I think we're reaching the end of our presentation. So I'd like to thank you very much for your intervention. And I think we can now go through to the others. Thank you very much.